Hello, Jake and Artur here. We have just completed the first milestone of Canister Cloud, our Dfinity grant project. Canister Cloud is a platform designed to store, share and collect documents. It builds on the Dfinity DocuTrack app. And for the grant project, we will modify it by adding new features to make it practical for HR workflows, improving the UI for a smoother, more intuitive user experience, and enhancing security to make it robust for access control and document privacy. DocuTrack is only suitable as a demo because it lacks key security features. The objective of the first milestone was to set up the project architecture, restyle the UI, and address the security issues. Our first task was to fork the DocuTrack repository, install it locally, which we did, and it's also now deployed on mainnet, which is what you're looking at here. I've been working on developing the UI framework and design to make it user-friendly and fit with the Canister brand. The major task in Milestone 1 was addressing the security issues, which Artur will talk about.
Hello, my name is Arthur, and I'll be going over the security features that we've added to Canister Cloud. So the main thing was that the original IC DocuTrack app was creating the private key and the public and private key in the front end, and was storing it in the browser, basically in the local storage of the browser. So if you were, for instance, to, let's say, reload your cache, to clean your cache, you'll lose access to all your files because you won't be able to decrypt them anymore. And that is not the case with Canister Cloud, because the encryption is tied to your identity, because we use VET key. Let's try again. Because we use VET keys. So basically what that means is, because VET keys are built on identity-based encryption, IBE, the only thing that the user has to do to successfully encrypt and decrypt their files is to just log in. That's it, because it's tied to their identity. So that's all that they have to do. So okay, let me just upload some file. What is it? Downloads. Probably. Where do I have home? Some picture, some image, screenshots maybe. Okay, let's just upload the screenshot. Just some random image. Okay, let's view it. So yeah, it's getting the decryption key from the master key using VET keys. Okay, perfect, we have it here. And now let me just demonstrate. So we open a private window. We just copy it like this. Okay, so this is a private window. This means basically another instance of the browser. So just to demonstrate that the keys are not stored in the browser but derived using VET keys. Okay, is existing. I log in with the same internet identity with a passkey. Perfect. And this is the same files, and this is the one that I uploaded just a couple seconds ago. It's decrypting, and here you go, the same file. Amazing. So let me go over the code aspect, just a little demonstration of the code. So this is the private browser. So this is the candidate interface. There's a bunch of methods here. So this is the VETKD public key. So we can just call it. I can just show you, like, in a nice visual interface, the public key derivation. So as you can see, it's a vector. Okay, amazing. So in the code, this would correspond to this method here. And as you can see, it's calling the VETKD public canister, the VETKD system API, which is this canister that, here you go, the candid, the WASM, and Yeah, I mean, it's pretty amazing stuff because you don't need to store your keys locally, there's no vulnerability of that kind of thing. It's just tied to your ICP principal. So you just need to log in and it just works. And just to wrap things up, I want to thank the people, the very nice, kind people, and very smart people in the Dfinity forum for helping me figure out the VET key encryption. There was a whole thread about it in the forum. I just want to say thank you. And yes, thank you very much for listening.